Okay, so in the previous sessions, I have taken a session on simple harmonic motion and vibration. Okay. So today we will try to solve some numerical on main JE related to simple harmonic motion vibration. Okay. So simple harmonic motion and vibrations, like first to do vibration problem, we need to know what is simple harmonic motion. Okay. So vibrations, I have explained you, there are three major types of vibrations. One is free vibration, okay, and one is free damped vibration, and one is forced vibration. Okay. So this free vibration is something like suppose you have a spring. Okay. So you have a spring and you have a mass. Okay. So uh, let us say this is of mass m. Okay. So if you displace the spring, okay, you displace the spring by some external force, and then you leave it like that. Okay. If you assume that there is no air resistance, okay, so there is no friction at all, but in the real world there will be friction, there will be resistance. But if there is no resistance, what will happen? This mass, it will try to oscillate between two mean positions. So let us say this is my mean position. This is the center of the mass and this is my mean position. Okay, so if you apply some external force and if you release the mass, it will try to oscillate between these two positions. Okay, so it will try to oscillate between two extreme positions. First it will come down, like if when you see you are applying a force, okay, some force you are applying, okay, but that does not mean that that force is continuously being applied. You are just applying that force and you are removing that force. Okay. Yes. So you are applying that force and then you are just removing. Okay. So once you you remove that force, this mass will try to oscillate between these two mean positions. Yeah. Okay. So this whatever you are displacing, this is, you say that x. Okay, displacement x. Okay. So this mass with some external force you have displaced it, and it has tried to start oscillating between the mean position. Okay. So if there is no air resistance, it will try to oscillate indefinitely. For eternity it will keep on oscillating. Okay. But actually there is air resistance and it will not oscillate forever. It will die down. Yeah. So die down means, so this example is your free vibration. Okay, whatever I have told you, this is your free vibration. This is your free vibration. Okay. And now suppose because there is air resistance. Okay. So if there is air resistance, what will happen? First, initially it will try to oscillate between mean position. Okay. So it will try to oscillate between mean position. Then next, the amplitude of vibration will decrease. Okay. So it will try to oscillate, it will decrease. Because of air resistance, the amplitude of vibration will go on decreasing. Okay. So this first example is your free vibration. Whereas this second example, like when it happens like this because of the presence of air resistance, this will be your called free damped vibration. Free damped vibration. Free damped vibration. That means there is damping. Damping is nothing but your air resistance. Okay. So if the damping is present, the amplitude of vibration goes on decreasing. So what is called amplitude? Amplitude is the maximum displacement from the mean position. Okay. So this value is your amplitude. Amplitude of vibration. Okay. Amplitude of vibration, which we normally denote as A. Okay. So amplitude of vibration this is. Okay. Similarly, this spring mass system can also be equated to a simple pendulum also.
Yeah.
Okay, so let us say this is my fixture from where my pendulum is hanging. Okay, so let us say this is my pendulum. So this, let us say this is my pendulum of mass n. It is hanging from here. So if I just displace it by some force, and I displace it, so when I displace it, it will go up, okay, and then when I bring it here, okay, and then if I release it, okay, if I release it, it will go up. You bring it here till this point, then you leave it, okay.
Okay.
So then it will go down, then it will short up, it will come this
Yeah.
side, and then again it will go back, and again it will go back, okay.
Yeah.
So like this is my simple pendulum. So this is my extreme position, okay. So this is the extreme position of my simple pendulum, okay. This is my simple pendulum. So the length of the simple pendulum is L.
Yeah.
Okay. So there are some governing equation for time period and time period of a simple pendulum and time period of a spring mass system.
Yeah.
Okay, so this time period of a simple pendulum, we are not deriving it. We do some numerical on it. So T is equal to 2 pi
Root.
L square root L by G. Okay. So this is the time period of a simple pendulum. Okay. So L is your length of the pendulum and G is your acceleration due to gravity. Okay. Similarly, in this case, this is my stiffness of the spring. Okay.
Yeah.
If this is my stiffness of the spring, the time period of the spring is T is equal to 2 pi m by k. Square root m by k. Okay. So these things I have to remember. See, time period, the time taken to complete one cycle. Okay. So one cycle means what? It start from mean and go
till
this,
extreme position.
then come back, then it shoots up and then come back.
Yeah.
So one cycle, that is completion of one cycle, and the time period of a simple pendulum means time period of a spring mass system is equal to T is equal to 2 pi square root n by k. So these are the two major formulas you should always remember to be able to solve any numerical.
Yeah.
Because when you are getting only 3 to 4 minutes to solve the numerical, you don't have time to derive. Okay.
Yeah.
So this thing you have to remember. Once you know the time period, you can find out the frequency. So frequency is nothing but 1 by t. Okay, so you can find the frequency. Similarly, there is something called angular frequency, which is nothing but your omega. Okay, omega is your angular frequency. So you know omega is nothing but your 2 pi by t, which is equal to 2 pi f. Okay, so this you know. So if you know time period, you can easily correlate. If there is in the numerical, if they ask you the angular frequency or whatever, you can find it out. Okay, so you can take a picture of it, then we will write down some formulas related to simple harmonic. So T is equal to 2 pi square root m by k. Okay. Okay. So and then there is something called velocity and acceleration in simple harmonic motion. Okay. So normally we can write simple harmonic motion. We can write it as a sin omega t. Okay. So let me write it as like the simple harmonic motion. Okay, can be represented as a sin omega t. Okay. I am not writing the phase angle here. Okay. Omega t plus phi. Otherwise you can write it. Okay. So what does it represent? So it is something like this. this is my sine curve. Okay. So in the x-axis I have omega t. In the y-axis I have the displacement. Right.
Yeah.
So x is equal to a sin omega t. Okay. Then so the numericals will be related to velocity and acceleration in simpler velocity, acceleration and energy also. Energy, okay, kinetic energy and potential energy. Energy in SHM. Okay. So there can be many numericals related to this. So Ax is equal to A sin omega t. So this is the equation of simple harmonic motion.
Yeah.
So that's how the displacement varies with respect to time. Okay.
Yeah.
So this is a sine curve. Okay. So it can also be a cosine curve. So you know the cosine curve is just like this. Okay. This is cosine curve.
Yeah.
What does it means? Like at t is equal to 0, that implies omega t is equal to 0. Okay. That implies a sin omega t is also equal to 0. That means at time t is equal to this is 0.
Yeah.
Okay. But in cos t is equal to 0, that means cos omega t is equal to 1. Okay. That means a cos omega t is equal to 1.
Yeah.
That's what you can see here. Okay. So x is equal to a sin omega t. Then you know velocity. Velocity is nothing but first derivative of your displacement.
Yeah.
So dx by dt is equal to d by dt a sin omega t, which is equal to omega a cos omega t. Right. So there can be a question: what is the maximum velocity in a simple harmonic motion? So v max will be equal to omega a, because cos omega t can maximum be 1. Okay. Then this is velocity. Similarly, you have acceleration. Okay. Acceleration is equal to dx, d square x by dt square. Okay. So this is nothing but d by dt, and then you know this is omega a cos omega t. Okay. So this will become minus omega square a sin omega t. Okay. So again, what is a max? A max is equal to minus omega square a. Okay, so that is the maximum acceleration in a simple harmonic motion. Okay, so you can take a picture of it. Okay, so now energy in a simple harmonic motion. Then many questions will be related to energy in a simple harmonic motion. Okay. Energy in SHM. Okay. So for a spring mass system, the energy is equal to the potential energy. Okay. In a spring mass system, suppose you have a spring mass system. So you have a mass. Okay. So you have mass m. Okay. And then you have a spring of thickness k. Okay. So the energy of this is, like say, I just say work, energy is nothing but work done on the system. Okay. So energy stored is equal to work done on the system. Okay. So what happens actually when your mass, okay, when your mass is trying to go down by a distance x, okay, a restoring force F is acting against it. Okay. So this F into x is nothing but your work done. Okay. Okay. So this work done is F is nothing but again kx, right? F is equal to kx. Okay. That is the restoring force.
Yeah.
So kx into x. Okay. And you take the average of it.
Half,
okay. You
half
take half.
kx.
Yeah. So half. So this becomes your half kx square. Okay. So this is the work done, or otherwise this is called as the potential energy of a spring mass system.
Yeah.
So potential energy of a spring mass system is equal to half kx square. Okay. So, but the maximum energy in a spring mass system So the total energy, okay, total energy
It's potential energy.
total energy in spring mass system is equal to kinetic energy plus potential energy. Okay, and the total energy is nothing but half Ka square. Okay, A is nothing but your amplitude. A is nothing but your amplitude.
Yeah.
A is nothing but your amplitude.
Yeah.
So so if you see like in a pendulum also, okay. So in a pendulum, it is oscillating between mean position. So at the end here, actually it is at the maximum height. Okay. So here at the end position of the pendulum, your kinetic energy is zero, potential energy is maximum.
Yeah.
Okay. So that total energy. So at this position, total energy is equal to Pe plus 0.
Kinetic energy.
Kinetic energy is 0. But here, this is Ke plus 0 at the mean position. Okay. So this is the total energy. But in between, it is Ke plus Pe. Okay.
Which is half K.
So you know your Pe is always half Kx square. Okay. Yeah. And your total energy is equal to half Ka square. Right?
Yes.
That means at any position, at any instant, your kinetic energy
half
is equal to half Ka A square minus x square. Half K. So your kinetic energy is equal to half K A square minus x square. So this is your kinetic energy. Okay. So if there is a question at amplitude when the amplitude is equal to when the displacement is equal to half of the amplitude, okay, what is your kinetic energy? So you can just put, instead of x you can put A by 2. Okay, so so those kind of questions also can come. Okay, yeah. So now you know that what is work done, what is this thing. Okay, yeah. Half Kx square, half Ka A square minus x square, and one is kinetic energy, one is potential
energy.
Okay. Okay. So you can take a picture of it. Okay, so we'll try to solve one or two numerical. Okay.
Next slide.
This one numerical will solve.
Okay.
So this is about energy in simple harmonic motion. Okay, so one numerical is like this. Okay. A mass 4 kg suspended from a spring of spring constant 800 Newton per meter. Okay. So let me draw it. Okay. So I have a spring. Okay. I have a spring and I have a mass. Okay. So I have a spring and I have a mass. And this mass is, my mass is 4 kg. My mass is 4 kg and my spring constant, okay, my spring constant K is equal to 800 Newton per meter. 800 Newton per meter. Because I know spring constant is nothing but force per unit displacement. See, K is equal to force per F by x, okay. So force has unit Newton and x has units in meter or whatever. So that's why they are given 800 Newton per meter. if the total energy of the oscillation is 4 joule, then the maximum acceleration of the mass is how much? They are asking what is the maximum acceleration.
Omega
Okay.
square.
So what is the maximum acceleration? The total energy. So total energy, that is TE, is equal to 4 joule. Okay. So this is the question. Then they are asking what is the maximum acceleration.
Omega square.
Acceleration. So this is the question. So I know my total energy is equal to half Ka square. Correct?
Yeah.
So half Ka square, the total energy is equal to 4 joule. Okay?
Yeah.
Right? So
K
now
we know.
my A square is equal to
8
4
by K.
into 2 divided by
K.
K is, which is 800. Okay. So my 4 into 2
1 by 100.
divided by 800. So it is 8 by 800, which is equal to
0.
1 by 100, which is, if you take, that
10
implies
power minus 2.
A square is equal to 1 by 100. That implies A is equal to 1 by 10 meter.
10.
Everything in 1 unit. So A is equal to 1 by 10 meter. Okay. So now they are asking what is my maximum acceleration.
Omega
So A max is equal to omega square A, right?
Yes.
Omega square A. Okay. So I know my A. So omega
2 pi by T.
omega is equal to 2 pi by T. So 2 pi and
Into 1 by 2 pi into root of m by
2 pi, then time period is equal to 2 pi m by k.
K by m it will become.
K by m, right?
Yeah.
M by k or k by m?
It is m by k, but because it is
No,
in
let me
denominator.
write it first. M by k, right?
Yeah.
T is equal to 2 pi m by k. So 2 pi cancel. So it becomes k by m. So this also is a formula you should remember. Omega is equal to k by m. That also you should remember. So omega is equal to k by m, you know. Okay.
K
So,
and m we know. 800 by 4.
So omega is equal to, my k is equal to 800.
M
M is equal to
4.
4. So that then square root, right?
Yeah.
So this is 200 square root,
Yeah.
right?
Yeah.
So
root
omega,
2.
so my A max is equal to 200 square into A, right?
A is 1 by 10.
A is equal to 1 by 10. So let me put it as 200. Okay, 2 square root, then square means it is 200 into A is equal to
1 by
1 by 10.
10.
So the answer should be
20
20.
meter per second square.
Okay, so my acceleration, maximum acceleration is 20 meter per second square. So this is the answer. Okay, so this type, so to solve this numerical, what are the things you should remember? What is the formula for maximum acceleration? That is what you should remember. It is omega square A.
Yeah.
Then for omega you need to know this
2 pi
formula
by
also.
K,
And
K
for
by-
acceleration you need to know the total energy
K
formula also. So to solve this problem you have to know 3 to 4 formulas. So by knowing 3 4, so that's why in JEE not everything is direct. To solve only maximum acceleration, you have to remember 3 different things. Then only we are able to solve it. So nothing comes that easy in main JEE. Okay. Okay, fine. We'll in the next session we will solve some more numerical on simple harmonic motion. We will solve something related to free vibration, pre-damped vibration, and forced vibration. Those are very important things. Okay.